morning, good afternoon, and good evening. I'm Robert Kauchi, presenting to you the highlights of boiled cassava. These are contributions from NaCRRI Namlonge, from CIAT Colombia, CERAT France, and FSA in Benin. The outline that I'll follow, I'll share with you progress under work packet 1, work packet 2, work packet 3, 4, and 5. Work packet 1, basically this was work done in Uganda and Benin. And for the case of Uganda, the major accomplishment was zipping up this into a special issue. And in that special issue, we had basically two major messages. One, that softness was a highly preferred trait, and in-ground storability was equally an important trait. Now, other additional traits that were preferred by end users included high dry matter content, non-bitter varieties, disease resistance, early maturity, and drought resistance. Now, in Benin, 5 traits were highly desired for boiled cassava, and 4 traits were undesired for boiled cassava. Among the desired traits, you can see softness, mealiness, and sweet taste. Now you see that the desired traits in Benin for boiled cassava and the ones from Uganda are the same. And in terms of also the undesired traits, in terms of bitterness, in terms of hardness, are also the same. So meaning that both findings reinforce that the traits of boiled cassava desired are the same whether in Uganda or in Benin. Work packet 2 achievements come from work done in CIAT, in Uganda, Benin, and France. Beginning with CIAT, there were studies to see the effects of pectins on the quality of boiled roots. And from that study, which basically fits within frameworks of proof of concept, it was confirmed that firmness of boiled roots increases with the level of non-methylated pectins, as you can see from these plots. Secondly, from CIAT, the major accomplishment was in terms of developing the SOP for assessing cooking time, and this SOP describes the sampling, the sectioning, the duration of the cookings, and all this dataset has been summarized into this publication that has got mainly 5 major take-home messages. The first one is that cooking time as a key attribute has good genetic variation, which means there's a possibilities for selection and improvement. 2, that water absorption, and especially that takes a duration of 30 minutes, can reliably predict cooking time. The same happens with relative density, it can reliably predict cooking time. And fourthly, that cooking time had no correlations with dry matter content. And in the end, this protocol or these methods of water absorption can be a medium-term throughput method that can be used in assessing cooking time, which is a very critical attribute. This dataset still from CIAT shows the relationship between cooking time and water absorption, and it reinforces the fact that cooking time can be reliably predicted by water absorption, and because there's a linear relationship that exists, and this relationship is still being investigated further by additional datasets. And I want to highlight here that this achievement here contributed the success story from Cassava, which you'll hear later on during this meeting. Also, from the work done in Uganda, it was possible to tease out the 21 descriptors that describe boiled cassava, and these were segmented into appearance, texture, taste, and aroma. And when we try to look at the relationships between the sensory assessments and water absorption and penetrometer readings on either steamed or boiled cassava, we see that the sensory analysis correlated very well with penetrometer readings for steamed cassava and for boiled cassava, meaning that penetrometer is still a very good predictor in terms of softness, but in this case the sensory was negatively correlated with the sensory analysis. This here we are trying to highlight on the traits that are segmented under appearance, taste, aroma, and texture that constitute the 21 attributes that define boiled cassava. Under work packet 3, most of this work was done at CIAT and at NaCRRI Uganda. And here, in terms of tools that are being used, we're using the SD quality spec, which is a handheld NIRS, meaning that it can be used in the field, and also the benchtop force. So in terms of CIAT, there's some excellent work that has been done there, classifying varieties into short cooking and long cooking, and that has been able to improve on the predictions for softness or cooking quality. And this is an addition to other methods that have been utilized for dry matter, carotenoid, and starch content. So at CIAT still, more efforts are underway to explore deep statistical methods to improve more on these predictions. In Uganda, similar efforts have been ongoing, trying to look at boiled cassava at varying times, 15 minutes, 30 minutes, 45 minutes, and trying to see how NIRS can predict this. And we can see that the predictions range between 0.3 R squared value range between 0.3 to 0.5, and this was the initial efforts that we had worked on using penetrometer. Now with water absorption, we're trying to run more analysis to see if we can improve on these predictions, and current efforts have been working more on a larger set of germplasm that is being evaluated in 2 locations. In terms of data collation and management, 2 platforms are being used, the Cassavabase and RTBfoods. So for NaCRRI, within Cassavabase, we have been able to upload 1, the spectral data from all these trials, 2, the quality traits with defined ontologies, that is softness at 15, 30, and 45, then readings from the texture analyzer, all that have been uploaded onto Cassavabase. But also you can attach data onto Cassavabase. So all data that was done on sensory analyses and methods have all been attached to the respective trials within Cassavabase. Now the same has been done at CIAT, whereby all trials at CIAT related to RTB and traits have also been uploaded onto Cassavabase. For work packet 4, I'm going to share achievements at CIAT and Uganda. Beginning with CIAT. At CIAT, there is a pipeline on variety development, a pipeline for population improvement, and a pipeline for trait integration. Within variety development, efforts are basically to enhance or improve cooking quality in elite populations. Under population improvement, efforts are to blend cooking quality and dry matter content. Like you notice that softness, water absorption, and dry matter content were not correlated, so efforts are underway to increase on these traits in this population. Now in trait integration, cooking quality is being selected together with the stress traits, and of particular focus here is CMD resistance and brown streak resistance. So this kind of describe the ongoing efforts in terms of breeding at CIAT. Now also at CIAT, there is a very exemplary example on how information is connected between the work packets. So within here we see the connection between traits measured in work packet 2, tools developed in work packet 3, how they're being integrated into a breeding program. The examples that we can share here, water absorption assessment, which is being used in early selection stages, and also the NIRS, which is being used in early selection stages to help generate data, and that data to help in selection. So in these early selection stages where you have more individuals, you can see that high throughput methods like the NaCRRIs become very relevant. So we're also able to see that when you look at these box plots, when you compare selected quality traits, dry matter content, beta carotene, total carotene content, when you compare between selected and the unselected population, you can see that in the selected population there is less variation but improved overall mean or median as compared to the unselected population. You can see, and all these patterns are in the desired direction. That is very consistent for dry matter content, for beta carotene content, for total carotene content, and then for water absorption, which is a predictor for cooking time. In Uganda, the same thing is being done, whereby traits that have been perfected in work packet 2 and tools that are being used in work packet 3 are being integrated into breeding trials. And in this case here, we've applied these to uniform yield trials that were established at 4 locations in Uganda. That's Arua, Namulonge, Serere, and Tororo. And you can see, and this was basically done in white-fleshed and yellow-fleshed populations. So you can see differences in terms of genotype and location, and that's why we basically use blobs for selection. But also here you can see the contrast in white and yellow clones for those traits. I'm shifting to work packet 5. So under work packet 5, we basically focus on the TRICOT studies here, which highlights the connection between RTBfoods and next gen work in Uganda. And for the TRICOT, we basically tested this with elite clones, 11 elite clones, and these were tested on 240 farmers. And the 240 farmers were sourced from 6 districts, and within each district had to select 40 farmers. The target products here that we're focusing on are products of boiled cassava, are regions where boiled cassava is important, and regions where flour-based meal is important. So ideally, each farmer receives 3 random clones that he tests on his farm, making a total of around 60 replications for each variety. Now, at each farmer's field, farmers rank on a very simple procedure, worst and best, for traits displayed from 1 month, 3 months, 6 months, 9 months, and 12 months. However, for this presentation, I want to share the correlation or the assessments done on quality traits and the overall liking. And the overall liking here, I prefer the overall liking for the boiled cassava or the overall liking for the flour-based meal. So on the left panel, it shows you the correlations between selected quality traits and the overall liking. So you can see that farmers, the choice of the variety that they liked for boiled cassava, there was a very strong correlation with taste, and there's a very strong correlation with cooked well, meaning that cooking well and taste for boiled cassava were major drivers for the farmers to select or to like a variety. When you go on to the flour-based meal, which is in the right panel, you can see that when you look at the attributes of ease of peeling, ease of drying, mingling, stickiness, taste, texture, and color, you can see the taste was a major driver for the selection of a variety destined for a flour-based meal. So in terms of activities to conduct during period 4 at NaCRRI, CRT, Benin, we shall continue in terms of validating phenotyping methods and also applying phenotyping methods that have already been applied. We shall continue to define ontologies, upload the respective sensory data, and also undertake genetic analysis. I want to thank you all, the teams from CRT, Uganda, and Benin, for making this contribution. Thank you so much for listening to me.